So two particles can move freely along two parallel tracks. They both start adjacent to each other. Particle A starts from rest with an acceleration function of a of t is equal to 6t minus 14. Particle B starts with a velocity of negative 48 and an acceleration function of a of t is equal to 14. During the first 10 seconds, there are two times, not including the start, when they are adjacent to each other. Find these two times, giving your answers in a comma-separated list. Okay, so first we want to find the velocity function for particle A. To do that, we're going to take the integral of acceleration, which becomes 6 over 2 t squared minus 14t. And that's going to simplify out to 3t squared minus 14t plus c. Alright, now this c is kind of a problem, but we can solve it because they told us that particle A starts from rest. So when it starts at 0 seconds, its velocity is equal to 0. So if we were to plug in 0 for what we have right now and set that equal to what we know it's supposed to be, we know that c is equal to 0. So our final velocity equation for particle A would be 3t squared minus 14t. Now the next thing we need to do is find its distance function by taking, again, the integral. And that would be 3 over 3 t cubed minus 14 over 2 t squared plus c. This would simplify into t cubed minus 7t squared plus c. Now we're going to leave the c here for later because we have to do all of this again for particle B. So we're going to take the velocity by getting the integral of a of t, which would simply be 14t plus c. To find c again, they told us that particle B starts with a velocity of negative 48. So at 0 seconds, its velocity is equal to negative 48. So again, we just plug in 0 and set it equal to what we know it's supposed to be. And from here we can see that c is equal to negative 48. Our final equation is 14t plus negative 48. From here we can also find our distance formula, which is 14 over 2 t squared minus 48t plus c, which simplifies into 7t squared minus 48t plus c. Now, all we need to do now to find when they are adjacent to each other is simply when their distances equal each other. So we're going to take that distance formula and set it equal to this distance formula. Now these c's, you don't have to worry about them. If you were to move everything to one side, each c would be minus to the other side. So they would just cross out. Now let's move everything to one side. I like to keep my exponents with the highest number on the positive side. So we're gonna move it to the left side. So we get t cubed, moving this over to here. We get negative 14t squared, once again moving this to the other side, plus 48t is equal to 0. Now we can simply factor out. So we're going to start with t times t squared minus 14t plus 48. Now, what multiplies to get 48 and adds to get negative 14? We could try 12 and 4. That would not work. 6 and 8. I think that would work. So it's going to multiply two negatives to get this, and then add two negatives to get this. So we're going to do t minus 6 and t minus 8. Negative 6 times negative 8 is equal to 48, and negative 6 minus 8 is equal to negative 14. So we know that their distances are the same and they are adjacent to each other at 0 seconds, 6 seconds, and 8 seconds. The problem asks us for when they're adjacent, not including the start. So 0 seconds is out. And our final answer would be 6, 8.